So celebration one, um, it's we're in week 4, so it will show up in the week 4 folder. Somebody's actually taking it tomorrow, so the folder is going to suddenly open up, but there's not going to be anything there. But it's just so Vincent can upload his piece to me. So it's scheduled for this time on Wednesday from 6 to 8. I know there's 3 other people had a conflict and they were going to take it earlier on Wednesday. So like at 4 or 4:30. So I'm going to open my office hour early for them. And so if you are somebody who needs to take it early, because I'm pretty sure there's 3 of you who have like different choir practices on Wednesday night. Like the whole town has choir practice on Wednesday night, which is awesome. You just are going to have to come to my office hour and then I will email it to you. For the rest of you, at 6 o'clock, it is going to show up. The document will actually suddenly show up in the week 4 folder, and you just download it. If you're able to print, that's wonderful because it's all in front of you. But if you can't, just do it on a piece of notebook paper. If you're like Isabella and you have a tablet, you can absolutely do it on a tablet, your drawings and stuff, if you're comfortable with that. And you do get 2 hours. So when we did it in class, they had an hour and everybody finished in well under an hour. I give you 2 hours because I have learned that in this atmosphere, even at home, even when it's quiet, there are disruptions that happen. And so it's harder to be as focused. You can have notes. You do not need to be on Zoom. I will be on Zoom for the whole time. And again, I'll be on here from 4 to 6 for office hours. And also those of you who have to leave by 6, that way you have a full 2 hours. So if you have questions, you can come on and then I will need to see you. So I email it to you. You will still upload it. It's just, you won't be able to download it except from the email. The other comment is the other thing that happens on Wednesday, or actually on Thursday, some of you have a missing assignment. So that might be a study set. It's just a 1 point late fee, but it does have to be in by Wednesday. Or if you're missing a worksheet, or if you're missing a lab. So right now they're blank grades, so they don't show up as a 0, but they will become a 0. So just please make sure if you're missing any grades, there's like 1 or 2 of you are missing a lab or something. And if you need an extra day to get a lab done, just talk to me, send an email. But it's kind of like we move on after this. You guys have kind of a nice time because this Saturday you don't have a lab due because you're preparing your presentations for Monday. And I think there was a synopsis in the week 2 folder, but you will be next week doing presentations. So you're going to be sharing your screen, and so using a PowerPoint or Prezi or Google Slides, and you'll want like 5 to 8 slides. You want to be interactive. I did this last week with my other class, and they blew me away. It is actually something that's really fun on Zoom. You will all have your cameras on for the 2 hours so that you can see other people's faces. There's a way you can make all the faces disappear. So if when you're presenting, you don't want to see any faces, I would love to see faces again. Every time I listen to a church service, that's one of the things they always comment, that how wonderful it is not to be staring at a camera. But you will talk for your 5 to 8 minutes. So that's usually 5 to 8 slides. We like pictures, lots of pictures. Not a lot of words. You can have a few words to kind of keep bulleted lists so that you can follow along. Sometimes that helps. And just talk to us. Just have fun, be conversational. You can make a quiz out of it. You can ask us questions. It's kind of hard to give us prizes since we're in this, but you can do a virtual high five or something. After you present, we'll go back into that main thing where you can see everybody. And again, the class will be half the size. So there'll be like 9 plus me, 10 of us. And you will ask questions. So you'll ask questions to like 3 people. So there's like 9 presenters in each group. So 3 of the other people you'll ask a question to. And you're also going to write comments that you will upload in a folder. You don't have to turn in a paper. The only thing you're going to turn in is your comments for your classmates about what you liked. And I'll talk about all this at the beginning. Is there any questions about that? And you can always email me if you have a question. The other comment I wanted to make for next Monday, yeah, you know, it'll be fine. If you've never shared your screen, we can practice. I'll be on like 5 to 10 minutes early. And so if you're worried about sharing your screen, it's really simple and everyone figures it out. Jeremy did it with me last term, and so he can tell you. And it actually works really well in this environment. I don't know why. The class presentations have been really fun. Maybe because I don't have to talk and I get to see faces. All right, so drawing. I recommend colors. So again, these were actually, apparently you can get like big packs of like 20 or something of these, but having colors is really helpful. That erase. So I don't know why I'm using my red pen today. Underlining the ending. So heptane, you can write out carbons or you can do zigzags. And so this is 2, 4, 6. And so at number 4 is a Tert Butyl. So this is the one that was on your worksheet today. So the Tert Butyl will look like that. I will also draw it with the carbons. And then at number 2, we have a methyl. So if you do the sticks, that is fine. Or you can draw the carbons. 1, 2, 3, 4, 5. I think it's impossible to teach this without counting out loud. So at number 2, we'll have a methyl. And then at number 4, a Tert Butyl. I have some people who do like a mix of them, but a Tert Butyl is a carbon with CH3s surrounding it. And I should have done a different color. You can either draw your H's in, but you have to, if you show the carbon, you have to show the hydrogens. And so if you show the carbon, the sticks mean hydrogen. If you do zigzags, the sticks mean methyl. Questions with that?
Yeah, so we could write it both ways then, sticks or carbons.
Do one way or the other, Vincent. You can do either way. I recommend don't doing both. Pick the way that you like. Like you like the zigzags. Some people like when we get to the triple bonds, they don't like the zigzags with the triple bonds. So yeah, do which way you're comfortable with.
Perfect.
All right. On this one, again, underlining or circling the main part. This is where color is really nice. And cyclopentane. It is a cyclo, so this is the pentagon. That's probably the most missed thing on this one. And then wherever you want, you can put number 1. That can be at anywhere. That's a chlorine. And then at 3, an isobutyl is the one that has an elbow before the peace sign. So that's what our isobutyl. Reminder, iso starts with an I. If you wanted to show nobody shows the carbons on a pentagon, but this would be a CH2 and then a CH with this. It's a T, but you're attached like to the bottom of the T. All right, benzene. What I commented on the study set is make sure you put your circle in there. M means 1 and 3. So you do not have to use OMP if I ask you to name them. But if I use it, you need to know what it means. So we're going to put a chlorine wherever you decide number 1 is. And then at 3 is another chlorine. And then hexene. So this is trans, so we're just going to zigzag. And So here's number 2 is my double bond. And then at 5, I would have a methyl. If you drew it with carbons, at number 2, you have a double bond, and then you would put your hydrogens either both up or both down. And then at 5, you would put a methyl. And then you can either fill your hydrogens in or you just show little sticks. So again, back to Vincent's question, one way or the other, whichever way you're comfortable with. So I always start the tests off with drawing because that usually relaxes everybody. And you guys, most of you are doing the zigzags, and so that's perfectly fine. All right, on this one, we have to find the longest chain, and there's 2 possibilities. So one possibility is you could start here, 1, 2, 3, 4, 5, 6, 7. And so we get to heptane either way. You could also start here, 1, 2, 3, 4, 5, 6, 7. So either way we go, it's heptane. There is only one right way. Now, there is part credit, so if you went the wrong way, as long as everything else was good. It is the one with the red numbers. So you want where you're going to break it into more side groups. So those are all my side groups, and that's where it's nice. So we'd have 1, 2, 3, 4, and then 5, 6, 7. So ethyl, ethyl, and methyl. So we have a 3,4 diethyl. So longest possible chain for alkanes, this is the hardest part with alkanes. And if there's 2 ways you could go, you go the direction that breaks it into more side groups. And then we have the methyl at number 2. Questions? All right, the next one, here's going to be my number 1, because I want my side group at the lowest number possible. So octane. And those are methyls, so 2,6-dimethyl. All right.
Is that one trans because it hooks around?
No, because it's not a double bond.
Okay.
Yeah. So this one is trans. I'm sorry, this one is cis. I can't, you know what? None of you caught that. I screwed up there. You're all just being so nice. It's Monday, and I'm like going, how can I be tired? It's Monday. But so I apologize when the zigzags make so much more sense on my brain. If you draw the carbons out, I drew cis. Trans, the hydrogens are opposite each other. In cis, this one is cis. They will be in the same direction, or the main chain is going up on both sides of the double bond. So 1, 2, 3, 4, 1, 2, 3, 4. Either way I start, my double bond's at 4, 5. This CH3 2, I recommend you cross out the 2 and redraw one of them. So the parentheses drive some students crazy. A CH3 cannot be part of a chain. It always is on the outside. So it's it can be at number 1, but you can't have a CH3 at number 2 because the carbon would then have too many bonds around it. So this would be 1, 2, 3, 4, 5, 6, 7, 8. If I'd started in the other direction, 1, 2, 3, 4, 5, this methyl side group would have had a higher number. The double bond is smack in the middle of this chain, so it didn't matter. So this is octene. So you want to watch your ending. And 4-octene and 2-methyl. And you want to remember, and there's a dash, say cis at the beginning. Again, I'm always amazed because there's always one or two people who get every one of the names perfect. I mean, I've already saw that I was not perfect. There's usually, you know, little pieces. So if you forgot the cis, that's like half a point off. All right, here, numbering, this is 1, 2, 3, 4, 5. That is a chlorine. So again, that's why I will be on Zoom. You don't have to come on Zoom except when you turn your test in to make sure it's submitted okay. And this is going to be a methyl group. So the triple bond takes preference. So it's a 2-pentine, YNE. And at number 5, we have a chloro. And at number 4, we have a methyl. And then 2-pentine. All right, questions? All right, so this is, you will have a couple of these where they're named wrong. So the trick is make your drawing, and you can do zigzags. If you do carbons, just leave the hydrogens off. So some students who do zigzags revert to drawing the carbons. So we start with hexane, and then at number 4, there's going to be a methyl, and at number 4, there's going to be a sec-butyl. And sec-butyl means you have 4 carbons in a row attached to the second one. So if you just drew like that, that's what it would look like. Our numbering, our longest chain is much longer. So we would do 1, 2, 3, 4, 5, 6, 7. And those are all side groups. So it's a heptane with a 4-ethyl and a 3,4-dimethyl. Yes, I did it right. Sure I did. If you did zigzags, you would do your hexane, and then at number 4, do our methyl up. And a sec-butyl would look like that. So again, our numbering 1, 2, 3, 4, 5, 6, 7. So we have our methyl, our ethyl, and our other methyl. Yeah, I don't know. I think this is really fun because they're all like little puzzles to figure out. And so I always love doing puzzles. All right. So on the next one, pentane. So again, if you like zigzags, you draw your pentane, and 2-methyl, 5-methyl, a 2-ethyl, and a 4-ethyl. Or if you draw it out, 1, 2, 3, 4, 5, 2, 5, methyl. So our longest chain is much longer. There's different ways you can go, but it comes out the same no matter what you do. So 1, 2, 3, we get a methyl, 4, 5, 6, 7. And then there's an ethyl at number 5. Oh, we almost got the same name. So 5-ethyl. And then we have a 3,3-dimethyl. Anybody get them? Both? Heptane. This is where I miss seeing you all because there'll be like one person raising their hand going, yes, I got it. So questions with that. So draw what's there, leave the hydrogens off if you draw the carbons. You can do your zigzags, just draw it and name it. You're going to have to renumber. And this is where having the colors where you can erase. So draw it and then you're going to renumber it and find if there's no questions. So do you guys want 5 minutes, or you want to just go for it with this page? You can pause for 5 minutes. All right. So let's do this. We'll use blue now. So what's wrong with each of these? This is where we're looking for that carbon wants to have 4 bonds. So right here, my first one, when you have a double bond, you can't have a CH3 on a double bond. So this one, you have 5 bonds. So you can either say 5 bonds or too many. This was something I think on the very first study set, and that was actually something else I meant to say is I recommend redoing your study sets. And if you want your worksheets, the study sets you should have self-graded and stuff. So you can print them if you want, or you can just look at them and try them again. But that's really great practice. This is really good practice too. The worksheets are just more practice. Also looking over the notes and stuff. So yeah. Usually there is only one thing, but I'm just gonna make sure, yeah, that one's okay. This one on the one below it, if it's single bonds, this has only 3 bonds. So if it's a saturated, which it is at this part of it, the CH3 should be at the end. And looking at the double bond, this carbon has 4. Everything else looks good. All right, on this one right there, that one has only 3 bonds. Oxygens, we want 2, so it has a hydrogen in a line or a double bond. And so on this one, that carbon there has 5 bonds. So questions with that? A couple things I don't think I said it really clearly. So your celebration again is scheduled for Wednesday from 6 to 8, and you don't have to come to Zoom until you turn it in, and then you just come and check in with me to make sure I can see it. I actually wanted to compliment this class. I've had no issues. So it's probably because it's a second term chemistry, and so you guys seem to have no issues with uploading your assignments and stuff. But just when you submit it, just take a quick look to make sure you can see it, and then come on and I'll give you a thumbs up. And then also if you have any questions, so while you're taking it, if you run into a question you're not quite sure, you can come on, and I only let one person on at a time. And that way I can talk with you if you get stuck or need help or just need clarification on something. For those of you who need to do it early, from 4 to 6, if you come on with a question, we can go into a room, or I can kick the other people out or something. Yeah, and then there is actually, I realized since you guys don't have a lab due Saturday, if you have a missing lab, there's a couple of you who do. So that would be labs 1, 2, or 3. You would just have to have it in by Saturday. And any late study sets and stuff, we really want those in Wednesday because that's on this. But and that way we move on to the next stuff. All right, this is the isomers. So isomer means the first one, and again, this is something, if you weren't sure, you could come on. This is saying these are hooked up like that. Yeah, I will do my best to make sure I don't have a typo. I do sometimes have, oh, I know the other thing I was going to say is you can absolutely use your notes. I can't control that in this environment. And so to say no notes, somebody's going to use them. Notes do slow you down. And so it is a timed, you do have only 2 hours. And I don't think you'll need the full 2 hours, but you can have, if you get stuck and you can't remember, oh my gosh, what's 7 carbons called? It's okay to look or to make a little note card so you have everything organized. All right, on A, they are the same or identical. So they're both butane. On B, so we had something like this on one of the first 2 study sets, so especially those first ones to go back and refresh and stuff. But they both have 1 nitrogen. It's all single bonds. You don't have to count the hydrogens. If they're all single bonds, these are isomers because the nitrogen moved around. So the nitrogen, the hydrogen's there. It's in between the carbons or it's outside the carbons. So isomer means that we've rearranged. So defining an isomer down here on number 6, it's the same formula, but we have rearranged the bonds. All right, so we will run into lots of isomers. That's like one of the big terms in organic chemistry. All right, this one is no relation. And they may see the thing like right off, I can see without having to dwell on it.
The oxygen?
What about the oxygen, Sammy? Or somebody said?
It's not the same bonds.
No double bonds.
It has to do, Vincent, you have it. This one, there's a double bond. So this means it lost hydrogens. So it's different number of hydrogens. So as soon as I saw this one has a double bond and this one does not, I know that they're not related. I think the carbons are different also.
I thought there were a different number of carbons. So does that make
They
it
are,
also
but
no relation?
it is. But one of
Okay.
the things, like without having to count, because one of the things I found when you're in test mode, sometimes our counting skills are funky. But I just look at it and immediately say, whoa, there's like the next one. Again, double bond, and this one there's no double bonds. So again, there's no relation. And that's a lot faster than going 1, 2, 3, although counting is very calming, especially if you do it while you're breathing and your breaths. So on this last one where we get into bigger ones, they each have 1 double bond. Now the double bond moved, kind of to what Sammy was alluding. That's actually a good thing. Here are my double bonds between carbons. Here it's between a carbon oxygen. That means this can definitely be an isomer. So they each have 1 double bond. They each have 1 oxygen. And then you can count your carbons. So 1, 2, 3, 4, 5. So we have 5 carbons. And this has 1, 2, 3, 4, 5. So this is an isomer. You don't have to count your hydrogens. If you have that double bond, the double bond moved. That makes it an isomer. We actually have more isomer questions. No, we don't. I do want to add one more piece though. And it is, I sometimes do this in words. So let's just say you have 1 pentene and cyclopentane. Those are isomers. So why?
Is it because of the number of hydrogens?
How do you know?
The CX and H 2X plus 2.
Yeah, so that goes to the generic compounds. So I know because I wrote a rough draft of your test that there was a bunch of questions on, I think it was the first, second, and third. But when you go to an ene, a double bond, you lose 2. So the acyclic alkanes are basic starting point, right? So acyclic means we haven't made it round, whatever. These are the CXH2X plus 2. So the ends get the CH3, so that's the plus 2. So when we make a double bond, It's just CXH2X. So you lost the N, you lost 2 hydrogens. And when you make a cyclo, you lose the N's, so you lose 2 also. So recognize it's a pentene and a cyclopentane that end up as isomers because their number of hydrogens are going to be the same. So a double bond has the same effect as making something into a cyclo. A triple bond, well, that was the other thing I was going to mention. So triple bond, you could end up with something with 2 double bonds or a cyclo with a double bond. I sent out, so first my apology, but I sent an email yesterday. I sent you guys 2 emails by mistake, but the first email has a bonus in it. And only Haley has responded to it. It's a question about isomers. And so if you all respond by Thursday, everybody gets an extra bonus point. Right now, only Miss Haley has a bonus point. And yeah, the second email that was the C27H something, that was supposed to go to my Chem 106 class. So if you take Chem 106 with me, you see a prelude to what their bonus emails are. I think it just had information. Yeah. So do look at that. And if you're not getting my emails, you can stay after and talk. All right, boiling point. We are looking at surface area is the key. More carbons is the reason I would like to see there. So decane is 10 carbons versus pentane. B is not a fair question for right now, but we're going to answer it anyway. This has an OH, and so this is what we're getting to after your celebration. I didn't realize this was on there. They're all just the same organic compounds, but this is going to be able to H bond. So I don't know if you remember back in Chem 104, you learned about intermolecular forces. So once you add an oxygen, that always shoots the boiling point way up. That won't be on there. This test is about hydrocarbons. The only place you're going to see oxygens is in like a game like this or something. All right, on this one, it is this one. So this one has fewer side groups. So they both have 5 carbons. And so fewer side groups means more surface area. The dimethyl propane would just be like that. So it's more compact. More compact is lower boiling point. Questions with that? You'll see a small section on this test. These questions become much more on the next test when we start adding the oxygens. But for right now, we're just looking more carbons. If they're the same carbons, you're looking for fewer side groups. So it's more drawn out. This one's more compact, if you like that answer better. So more compact is a lower boiling point. And now we're looking at water solubility, not. So neither one is on A. And let's move that. C was on the next page by mistake. Again, these are not. They're only hydrocarbons. So if they're only hydrocarbons, they are hydrophobic. So the very first lab you did, there was a page at the end where you had to identify if they were hydrophobic or hydrophilic. So oxygens make things hydrophilic and nitrogens. And then there were the ones that were amphi, where they were hydrophobic and hydrophilic. So there is a question, there's like a question with 2 or 3 molecules that you're going to do that with. So if it's just long carbon chains, zigzags, hydrophobic. If you see oxygens or nitrogen, if you see positives or negatives, that's hydrophilic. And if you see both, like oxygens and then along zigzag, that's the ones that are ampy, whatever ending you want to put on it. All right, B is not really with this, but that's kind of what I was just talking about. This OL is an OH, and so it is, yes, water soluble or hydrophilic. And so it would be shown with pictures, like it was on that first lab, the last page. So you can go back and look at that. Is there any questions with this page? The other thing that's not on here, sorry, I asked for questions and I started talking, is bond angles. There is one question. It's like 1 point, I think. And so we'll do it up at the top. It's the alkanes. Anybody remember what the bond angles are for the alkanes? Anybody there? Alkynes.
Are the alkanes bond angle 120?
Which one's 120? The alkenes?
Alkane.
Alkanes.
The alkenes are 120, the alkanes are 109, and the alkynes are the 180. So alkanes are tetrahedral. You remember learning those back with Lewis structures. There's 1 point, and I pick one of these. The alkenes are planar triangle, so they are flat. And the alkynes, that's why when we drew the alkynes, there's that line there. These are linear. All right. Try and think if there's anything else. Yeah, go back over your study sets. All right, let's take on reactions. And so reactions do become a big deal. I think that the celebration is 4 pages. So, and again, the first page, some of it is, it's similar to this. I think I give you more space. Yeah. All right. Can this exist as a cis-trans? So there's 1 point on there, a question like this, is if we just make a sketch, you can choose zigzags or you can draw your carbons. And the answer is no. He did zigzags. And it's because this guy, carbon 2, has, which methyl are we looking at? It has 2 of the same thing. So no. I think that was your 3rd homework set. There were some like that. All right, reactions. This was the study set 4 and 5. So we're going to draw 1 butene. And these, when we have the double and triple bonds, these guys are highly reactive. These are addition reactions. And I'm assuming you guys have the same questions. This is mine from last year, and I don't think I changed anything. So this is where I use the stars. You don't have to, but you will put both chlorines. So addition, the double bond is gone. That's the key. And something happens on each side of the double bond. So they each get 1 chlorine. If it is a butane or benzene, this is substitution. So you're swapping 1 chlorine with a hydrogen. So butane, you get 1 chlorine on there and then plus HCl. Now, there's 2 answers. So the other problem with substitution is you get multiple answers. So it's not multiple choice, it's that there's multiple answers. So does anybody see what the other possibility is?
Putting it on the end.
Yeah. Was that Ezra?
Yeah.
So you could have put it as a 1-chlorobutane or a 2-chlorobutane. So when I show it here, right, this is my 1, 2, 3, 4, and 2-chloro. And of course, the one up above is a 1,2-dichloro.
The alternative to putting stars is putting lines, is that right?
Oh yeah, you can put lines like I did here with the chlorines. Yeah, absolutely. All right. So butane, just a reminder how to draw this. If you're wanting to do zigzags, you can always go back to the carbons, but that would be 1, 2, 3. So 1 carbon in each direction. There's nothing before the 1, 3, 4. And excess means you just keep reacting. So this would also probably have a catalyst. I don't know what it would be off the top of my head, but you don't have to do the stars, but if triple bond, you got to add all around those stars. And you don't have to show the H, but it can be really helpful. You're going to get an H and a Cl and an H and a Cl. The Cls, this is the triple bond, is the rich get richer. The chlorines keep going to the middle. So this is where we get the 2,2-dichloro. Again, there's only one product. We don't get the plus HCl. So for addition, so A and C are addition reactions. So 2,2-dichlorobutane. The thing all three of these have in common is that we went down to saturation. So the reactions are making things saturated, meaning there's no more double, triple bonds. All right. I do have a note here. We did this on your homework in your worksheet. So with this, if we did that reaction, right, the ethyl gets added and you get the HCl. So we would end up with, I don't know if I put it on there, with an ethyl benzene plus HCl. That was on your study set. So it's similar like like B was. All right, combustion. So hexane, C6H14. So ane, we double the hydrogens and add 2. And combustion means plus oxygen. And you're going to get CO2 plus H2O. This is the only reaction, the whole term, you're going to get to write where you have to balance it. So there will be one combustion on there. 1 point is that you got that it's oxygen, CO2, and H2O are the products. So we're assuming it's complete combustion. And then we're going to balance. So the 6 carbons become 6 CO2s, 14 hydrogens, we get 7 H2Os. And you can at this point say, uh-oh, and double, or you can go with a fraction. So if you like fractions, you can do 9.5, so 19 halves. Or you can just double everything. So you would get 2, which makes this a 12 and a 14, so 24, 38, yeah, and 19. Again, there'll be one combustion, and balancing is worth 1 point. That's not going to make or break you. Actually, answer my email, and then you have a point to spare. And if you all answer it, you all get 2 points. I'm still dreaming this term. I'm like really dreaming. You guys came nowhere close the first time we did this. So do it this time. Answer my email. Yeah, actually, none of my classes have come close this time. I did want to make a comment at the very bottom of this page, and it's because I didn't really proofread because I had a really long week. like all of you probably. Actually, I didn't have a long week. The sun came out. That's what it was on Friday and Saturday. And I went and played out in the sun because I knew the rainy weather was coming. And so I had a wonderful long hike on Friday and a long bike ride on Saturday. So there's the only question from the labs is that very first lab, that last page where it asked you if it was hydrophobic, hydrophilic, or amphiphilic. There'll be like a couple molecules like that. All right, and then this is where I give you the products and you tell me how to get there. I do use words on the exam since it's take home. And again, you can have, if you have everything, all your stuff organized, to end up with them next door to each other would be just like this. So we would start with 1-butene. You could start with 1-butene or with 2-butene. Either way, it's going to work. 1-butene is probably better, that they will end up at the same position. And again, you can show me your beautiful reaction. You have to tell me what you're adding, which is HCl. And if you want to show it correctly balanced, that's great. Organic chemists don't balance quite the way that we do in general chemistry, so combustion. All right, how do we get an OL means an alcohol group, an OH. So this is the reaction with water and H2SO4. So we want the OH is going to go towards the middle, which means you don't have to show the H, but we would have to start with the double bond at number 1, so 1-pentene. 2-pentene would not work. You would get part credit, but 2-pentene, the OH would have gone to number 3. To get full credit, you would show me the H2SO4 as your catalyst for the H2O reaction. And I don't know if you guys still have that typo. I don't know why the L is there, so that shouldn't be there. Cyclohexane, and a reminder, in benzene as well as cyclohexane, we don't put a number if there's only one thing. So we just say bromo cyclohexane. If there's a double bond, the double bond gets the number 1 position, and then we'd have to number that. So if we're only adding 1 bromine, we would start with HBr. So an H would go to 1 position, and we want a double bond because double bonds are reactive. Halogens do not need a catalyst because they're so reactive. And that's all I got. Is there questions for the good of everybody? Oh, you can always dress up like a coal miner. Go ahead, Vincent. Did you have a question or?
Yes, I did. Is it possible if you may please redo the combustion again of hexane of D? How you got 9.5?
The 6 for the carbon, because there's 6 carbons over here.
Mm-hmm.
And so that gives me 12 oxygens.
Mm-hmm.
And I have 14 hydrogens. So 7 times 2 is 14 hydrogens.
Mm-hmm.
So that means I have 7 more oxygens. So that gives me, I have 19 oxygens. So over here, this would be 19 halves, which is 9.5, or you have to double. Does that?
That makes 100% sense. Okay.
I know I went through it fast, but I figured people go back and look at those. And again, it's 1 point that you can balance, but does that help?
Yeah,
Yeah, and
significantly.
it's been for you a while since you did Chem 104, so people where it's more fresh. Anybody else? Question? All right, I'm gonna stop and